Right, we're doing hydrocarbons. Right, okay, let's define hydrocarbon. A hydrocarbon is a molecule. Always start with that contains hydrogen and oxygen atoms, and then only. Stick all these three in. Molecule, hydrogen, oxygen atoms only. Right? You need to learn monkeys eat peanut butter, meat eat prop and bute. Meat has got one carbon atom, eat has got two carbon atoms, prop has got three carbon atoms, bute has got four carbon atoms. After that it's like pent, which is 5, hex, and so on. That's like normal polygons. You're looking at two types of hydrocarbons, alkanes and alkenes. Alkanes have got a single E, so it's a single, so it's a hydrocarbon. I'm going to write this in shorthand. Hydrocarbon has single carbon to carbon bonds. It is a saturated compound. Alkenes are hydrocarbons that have double carbon to carbon bonds. It is unsaturated. How do you test for an unsaturated or an alkene? You add orange, bromine, water, and it will turn colorless. If you have a unsaturated compound or an alkene. Alkene has two E's, so it is a double carbon to carbon bond. Right, you need to know this as well. The general formula. Let's start with this. What you do, let me write this down, CnH2n. What that means is if you've got 4 carbons, you double the 4 to get 8, so you'll end up with 8 hydrogen atoms. So if you've got 3 carbons, you double 3, you end up with 6. If this is the formula, you know it's an alkene, and the general formula is this here. Now all you do with an alkane is CnH2n as before, but add 2. So for example, if I've got 2 carbons, I've got 2 times 2 is 4, and then we add 2, so it becomes 6. So if I had C10, I would double the 10, it becomes 20, and then add 2, so it'd be H22. Okay, that's that done. Let's go. Right, okay. Use the letters above to select a compound that is not a hydrocarbon. It's this one. because it contains something other than a carbon or a hydrogen. Right, okay. One compound with the empirical formula. So what they're saying is if you cancel these down, where you're going to get CH2. So look, this is CH4. Whoa, don't know how that happened, but it did it. You've got C2H6. That is C3H8. That's not a hydrocarbon. This is C2H4. This is C3H6. Right, so it's if I watch this, if I cancel this down, they're both in the 2 times table. So there's 1 and 2. So that becomes CH2. I don't need to put this one here. Okay, same thing with this. I can cancel these down. 1, 3 in there, 2 in there. So it becomes C1H2. So I don't need this. I can cancel that out. There you go. Name one compound. Right, okay, so we can put T or U. Hello, 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 hello. Let's have a look at this. T or U. Let's get rid of this and what's going on there. Right. Next one. One compound that can form a polymer. Right. One with a double bond. So it's any of these two. T or U again. T or U. Right. Q and T. Q and T. Right. Let's look at this. This here is an alkane. How do I know that? There's one E, so there's single carbon to carbon bond here. It is saturated. It is a saturated compound. Right, now let's look at this. That's got a double carbon to carbon bond, so it is an alkene. Alkene, I can't spell alkene. Let's try that again. Alkene, it's got 2 E's, so it's a double carbon to carbon bond. It is unsaturated. There you go. Right, we need to do a test. What did we say? You add orange bromine water. Orange bromine water. And it will turn colorless. Okay, let's keep going. Draw the displayed formula. Displayed formula of an alkene containing 4 carbon atoms. Right, let's just look at this. You have something called a displayed formula. You have something called a molecular formula. Then you have something called a structural formula. And then finally you have something called empirical formula. Displayed is something like this. hydrogen, 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 hydrogen there, hydrogen there. So that's what it looks like. Molecular formula will be C2H6. Structural formula will be CH3, CH3. So all we did was we wrote that first, and then we wrote that part second. Empirical formula is hard to get your head around when you first look at it, but it's really, really simple. How many 2's in there? 1. How many 2's in there? 3. So the empirical formula is CH3. That means for every 1 carbon atom, you have 3 hydrogen atoms. That's all it means. Right, let's have a look. What's the general formula for alkanes? Right, remember we said for alkenes, it's simple. Double the number of carbon atoms. For alkanes, it's double the number of carbon atoms plus 2. Right, alkenes have the same general formula. State 2 other features of a homologous series. Right, homologous series are compounds in the same group. They have the same functional group at this level. So what I tend to do, I tend to write they have similar chemical properties. Right, what else do they have? They have a trend in physical properties. Right, this usually means something like this, right? So for example, if you've got a small hydrocarbon, as you go down, the chain length will get longer, and it'll go from gas, it'll just say, for example, go to liquid, and then it'll become loads of these, right, and then it'll become a solid. So this is a trend in physical properties. Right, you've got displayed formula. It's an isomer. What did we say an isomer was? Right, let's define isomer. Oh dear. Right, now started playing up. Unfortunately, we are in big trouble. Right. We'll have to discard it. Isomer is a molecule with the same number of same number of right, okay, no, I'll take that back. With the same, no, we can't do that. Same molecular formula but different displayed or structural formula. So I stick to displayed. Come on, I'm gonna have to change this. 1 second. There you go. Right, just have to live with that. Right, different displayed formula but the same molecular formula. That's the definition. Okay, let's try it. See if it works. Oh yes, it works. That's cool. Right, the pen keeps getting stuck. Right, so we know what an isomer is. An isomer is a molecule with the same molecular formula, but different displayed formula. That's it. So let's write that definition down. Molecules with the same molecular formula but different structural formula. Right. Why is decane? Okay, what's the definition for hydrocarbon? It's a molecule that contains only hydrogen and carbon atoms. So look, I've said only, and then I've said hydrogen and carbon atoms. Give the molecular formula for decane. So what they're saying to you, count the number of carbon atoms, 1, 2, 3, and because it's dec, you know it's going to be 10. 6, 7, 8, 9, 10. Because it's a decane, what I can do is I can double the 10 and add 2. I can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you've got 10 there. 20. 21, 22. So that's what it is. Good. I got that. Right. Now watch this. This is polymerization. This is polymerization. So you crack ecosane. That's a long chain hydrocarbon, and you make decane and ethene out of it. So if you notice, ethene is the monomer, and another ethene and another ethene. You join them together and it becomes polyethene or polythene. Right, that's a typo. It should be like this. Right. What is the name of given to this type of polymerization? So what did we say? What did we say now? Right. We need to learn two types of polymerization. One is called addition. This is where you get a few monomers, join them together, and you only get one product. So you only have a single product. This is called addition. The other one is called condensation. Right? As the name suggests, it condenses, it makes it smaller. So what happens is you get one of them, you get one of them, you get loads of them, you end up with one of these and one of those for argument's sake, yeah? Let's just do that. That's just for argument's sake. Right, now you notice here, you've got your main product that you want and you've got a little molecule on the side that you lose. Right, so you've got more than one product. This is called condensation, polymerization, because you've lost this little molecule, you have lost it. It has been condensed. What is this called? This is called addition, polymerization. Use the diagram to state two changes. Right. What happens, if you notice here, these double bonds break and you get short chain monomers and you end up with a long chain polymer. Right, okay. So you can say the double bond breaks on the monomers and a monomers. Right, okay, let's write it this way. This is probably the best way to write it then, yeah. Many monomers join up to form a polymer. There you go. And to form a long chain polymer. Okay. Explain why cracking is important. Right. First of all, always write this. There is an oversupply of long chain polymers or hydrocarbons. Next, there is a high or greater demand. There's a high demand for short chain okay, I was gonna be lazy, hydrocarbons, but I can't. Hydrocarbons, getting ready for exams, so we can't take shortcuts. Short chain, there's a high demand for short chain hydrocarbons. No, just such as gasoline. What do we call gasoline in the UK? Petrol. Now, right, cracking also produces alkenes that are used to make alcohol and plastics. Right. Dun 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 dun. That's meth. Right, okay. Look, it's good to know this, you know. This comes up so much. It's good to know it is ethene. It's an ethene molecule. It is an alkene. It is unsaturated. Learn all that. It is important that you learn this. Learn all that. Right, let's keep going. What is hydrocarbon? Hydrocarbon, a molecule that contains only hydrogen and carbon atoms. So we've used the word only, we've used the word hydrogen and carbon atoms. Done. Right. what is next? What does the term unsaturated mean? A molecule that contains double carbon to carbon bonds. Right. Compound A, B, and C belong to a homologous series, right? Homologous. Homo, same. Homeostasis, like homeostasis, like in biology. It just means steady state or same state. Right, name the homologous series A, B, and C. If it's, okay, double bonds. So it's got a double carbon to carbon bond. It is therefore an al. You know, it's got two double E, it's got double E, so it's got a double bond. General formula is CnH2n. So remember what we said, if we've got 6 carbons, I'm going to double 6, I'm going to end up with 12 hydrogens. Right, state 2 other characteristics of compounds in the homologous series. Right, okay, remember what I said? They have similar what? Similar, can you remember? Chemical properties. I also say they have a trend in physical properties. That's a good one to remember. Right, another one that's a good one to remember is they have the same general formula. Good. Right. Right. Isomer. Right. Okay. What's the name of compound C? Where is compound C? Right. 1, 2, 3, 4. Okay. 4. It's got 4 carbons. So monkeys eat peanut butter. So that'll be meth, eth, prop, and bute. So it'll be butene. I can get away with writing butene, or I can write bute 1 ene. Okay, what is the molecular formula of compound C? So the molecular formula is 3 carbons, no, 4 carbons, and if you double the number of carbons, you get the number of hydrogens for alkenes. Isomer, molecule with the same molecular formula and different structural formula. Structural, or you could even use the word here, displayed formula. It's up to you. The same thing is it's got the same number of atoms, so it's the same molecule in terms of the number of atoms and types of atoms, but it's arranged differently. It's arranged differently. Right, we need to draw, right, okay, the double bond is on the first carbon atom. So what I tend to do, I've got 4 carbon atoms, so I go, oh, no, I don't do that, I do this. I'll say 1, 2, 3, 4, I'm going to put the double bond there, single bond there. Now start counting, each carbon atom has 4 bonds, 1, 2, 3, 4, I stick hydrogens on the end of those, so I've got 1, 2, 3, 4, hydrogen there, 1, 2, 3, 4, hydrogen there, 1, 2, 3, and then 4, so stick a hydrogen there. So, right, that's one way. You could have also done this. We could have then put a there. We could have arranged it like this. There you go. Right, okay. Bromine water can be used to distinguish compound A from ethane. Right, complete the sentence to color change. Right, bromine water changes from orange to colorless. Right, right, if you notice, look, you've got that. So this is what's happening, right? So you've got this situation. I'm going to draw these bonds here. I'm going to add bromine and I'm going to get something. Now watch this. All that's going to happen here, this double bond's going to break, and that's what's going to happen. And one of these bromines is going to go here, and one of these bromines is going to go here. So bear this in mind. So that's what's happened. You've added them. It's an addition reaction. Okay, so we need to now write the formula. So we've still got, oh dear, we've still got 2 carbons, still got 4 hydrogens, but this time we've got 2 bromines. It'll be 1,2-dibromoethane, but they've not asked us for that. Right, okay, that's half an hour, and there's loads of these to do, so we'll put this on another video. That looks so familiar. Why does that look familiar? Haven't we just done that? No, we haven't. Okay, one thing you'll notice with this is super repetitive. So if you can go through all these and learn them, you're well on your way to doing hydrocarbon questions in your exam.